Another technique we have to solve systems of equations is the addition method. This a lot of steps here, man, 5 steps. But I think it goes much quicker when we do it. Write both equations with x and y variables on the left side of the equal sign and constants on the right. Write one equation above the other, lining up corresponding variables. If one of the variables in the top equation has the opposite coefficient of the same variable in the bottom equation, add the equations together, eliminating one variable. If not, use multiplication by a non-zero number so that one of the variables in the top equation has the opposite coefficient of the same variable in the bottom equation. Then add the equations to eliminate the variable. Solve the resulting equation for the remaining variable. Substitute that value into one of the original equations and solve for the second variable. Excuse me, and then check the solution by substituting the values into the other equation. So here's a good one, a good first example. We have x plus 2y is -1, negative x plus y is 3. So notice we have x and negative x. So if we add those together, x and negative x, that goes away. 2y plus y is 3y. 1 plus 3, negative 1 plus 3 is 2. And we divide by 3. Y equals 2/3. Now we're going to take that and put it into one of the two equations. I'll put it in the first one. So x plus 2 times 2/3 equals -1. So x plus 4/3 equals -1. And so I'm going to subtract 4/3 from both sides. X equals, now -1 can be written as -3/3 plus -4/3. So -1 and -4/3 to give us -7/3. So x would be -7/3. So the point is going to be -7/3 and 2/3. We can check that. So what do we have? We have -7/3 plus 2 times 2/3. Is that going to be -1? -7/3 plus 4/3 is going to be -3/3 is -1. That works. Try the other one. -7/3 plus, negative of -7/3. I was going to panic there for a second. Plus 2/3. So that's positive 7/3 plus 2/3 is 9/3, which is 3. Hey, that worked out. Okay, so that is the solution. Now, sometimes we're going to have something like this, example 5, where it's 3x plus 5y equals -11. X minus 2y is positive 11. So none of the variables line up. So what I would suggest is we take the second one and multiply it by -3. So we have 3x plus 5y equals -11. -3x plus 6y equals 11 times -3 is -33. Now I can add straight down. 3x and -3x, it goes away. 5y and 6y is 11y equals -11 plus 33. Let's put a plus out here. Is -44. So I can divide by 11. And y equals -4. So we could put that into either of the equations. I'll put it in the first one. X minus 2 times -4 equals 11. So x plus 8 is 11. So subtracting the 8, x equals 3. So 3 comma -4 should be our point. Let's put it in the first one. 3 times 3 plus 5 times -4 is -11. So 9 plus -20 is -11. That works. 3 minus 2 times -4 is 3 plus 8. So that's 11. Yep, that works too. Okay. Example 6. Solve the given system of equations in two variables by addition. Okay, so this one, we're going to have to do a little bit of work. Well, we can get rid of the x or the y. In either one, we're going to have to multiply both by something. So I'm just going to get rid of the x. So if I multiply the first one by 5, and the second one by -2, we're going to have what? 10x plus 15y equals -80, I believe. The -10x plus 20y, it's -2 times 10, -10, equals -60. Okay, so adding them straight down, 10x, -10x, that goes away. 15y plus 20y is 35y. And -80 and -60 is -140. So we divide by the 35. And y equals, I believe that's -4. Okay, then we could take that and plug it back into one of the other equations. I'll just do the first one. So 2x plus 3 times -4 is -16. So 2x minus 12 is -16. If I add 12 to both sides, 2x equals -4. Dividing by 2, x equals -2. So we're looking at -2, -4. And let's go ahead and check that. So it's 2 times -2 plus 3 times -4 equals -16. Is that going to be true? Is -4 plus -12 equal to -16? That's a negative there. That's true. 5 times -2 minus 10 times -4, is that 30? So is -10. Then that becomes plus 40. Is that equal to 30? Yes, it is. So it works. Okay, our last example for this technique. Solve the given system in two variables. So the first thing I do is I clear out the fractions in each case. So I'm going to multiply the first one by 6 and get 2x plus y equals 18. Second one, I'll multiply everything by 4 to clear out the fractions. So I get 2x minus y equals 4. And my initial approach to that was going to be like, okay, let's get rid of those x's. But I have a plus y and a minus y. We can save some time right there. And if I add them together, I end up with 4x equals 22. So divided by 4, x equals 11 halves. That's not the prettiest, but it's not bad. I'm going to take the 11 halves and put it in one of the two. I'll put it in the first equation. So 2 times 11 halves plus y equals 18. So the 2's divide out. So 11 plus y equals 18. Subtracting 11, y equals 7. So our point is 11 halves, comma, 7. I know this video is getting long. It makes me not want to do the check, but let's see here. 11, and I'll solve this complex fraction. 11 halves over 3 plus 7 over 6. Is that equal to 3? 11 halves over 3 is 11 over 6 plus 7 over 6. Is that 3? So it's 18 over 6 equal to 3. Yes, it is. And then 11 halves over 2 minus 7 over 4, is that equal to 1? So that's going to be 11 over 4 minus 7 over 4 equals 1. So that's 4 over 4 equals 1. Yes, it is. I just want to address one thing. The 11 halves over 3, that's like saying 11 halves divided by 3, which is 11 halves times 1/3. So that's where we're getting that 11 over 6. Same thing with 11 halves over 2 is 11 halves divided by 2, which is 11 halves times 1/2, multiplied by the reciprocal. So it's 11 over 4. So I'm not just pulling things out of thin air, but I am kind of moving on. For some people, I felt that might be beneficial to see where that came from. Okay, a little bit long video. Sorry about that. Next time we're going to talk about different types of solutions.